Hello, folks. Isn't it exciting? Somebody in real life in front of you. But we've not really got out, have we, seriously, for a while. So, this is a big presentation, and I've got 15 minutes, so I'm going to rattle through, but it is available for you guys to have a look at. And when we were looking for a title for this, right, somebody came up with Back to the Future, IPv4 Back to the Future. And the reason I put it in is because you can see I'm quite old. So I've actually lived through the IPv4 to IPv6, then no, it didn't happen, then it's going to happen and whatever. But what's interesting about that film is that when the first one came out, which was, pretty impressive film at the time, I think there were 2,000 people on the internet. And when the third one came out, so that was 1985, and the third one came out in 1990, and there was 300,000, but still not a huge amount. And it was another 5 years until we got the first RFP for IPv6. So you can see that, even at that time, we were thinking that IPv4 was going to run out, and we still only had, a few 100,000 people on the internet. Not working? Right. So, what have we seen during the pandemic? Well, actually, what we've seen in the pandemic has caused a huge growth in spending on infrastructure around the internet. Actually, any infrastructure has been huge. Any infrastructure that's around people working from home, not having to go into an office anymore. Remote working was the big driver for this. So 98% of all the companies that we surveyed said that they'd had an increase in demand, and 53% of those people wanted to scale up things like network infrastructure, and security were the big drivers on that. So I think that's pretty common across the globe. In the UK, it's the same, but across the world we have seen a massive, massive increase in service providers putting out more infrastructure. In the UK, of course, we've had the driver, which probably most of you guys know already. I'm not going to go through the details, but Project Gigabit's put 5 billion into access. Shared rural networks, another 500 million. And that's driven a huge growth in not just the massive service providers, which we typically provide, but also the smaller, up-and-coming regional and rural providers, adding to the networks. And our Prime Minister has backed it and put it in the public eye. So what we know is that there's a huge amount of growth that's going on in our industry. But what's the challenge? Well, the challenge is whenever you're going to build out a network, as you guys know, it's your bread and butter, you make a decision, right? Are we going to be IPv6? Are we going to be IPv4? We really like to be IPv6 because it's nice and elegant, it's very nice, but actually, we probably can't go there straight away because there's going to be some sites and places that people need to get to that are always going to be IPv4, and there's going to be some clients, endpoints, that are always going to be IPv4. So personally, I'm a bit of a Arduino guy, right? And so I know that every single microprocessor out there is currently running IPv4 stacks. Probably most smart TVs IPv4 stacks. In Germany, we know that they've not been able to move over from some of their major service providers because they can't get smart TVs, which are a big driver for networking. They can't get them moved over, so you can't go native IPv6. So we're left with the options. What can we do? Now, what we can do is we can take a technology like CGNAT and we can multiply those out, right, and get between a 32 and a 64 times amount of usage of every single IPv4 address. So if we look at the worldwide and global view of what's happening, we know that still 64% of traffic in 2021 is IPv4. And they predict by 2025, 65% is going to be IPv6. I'm a little bit cynical about this because I've been seeing the same figures for maybe 20 years. But what we definitely know, that only about 18% of 18.6, 18, 17, 18% of all websites are using IPv6 at the moment. So it looks to me like we're stuck with this technology for a good time moving forward. So studies show that we're going to have a substantial amount of IPv4 traffic that's not going to be able to, that's going to be there, and IPv4 hosts that are going to need to be supported. So we get down to the crux of this problem. Every single internet-connected device needs an IP address. And IPv6 is not backward compatible. Now, I'm more than happy to have an interesting conversation over lunch or whatever about the decisions and who made the decisions to make it not backward compatible. I sort of lived it at the time, being a programmer. But look, we are where we are. It's not backward compatible, and you have to make some decisions when you're going to build out these networks. So, here's the problem. We've now run out of resource. IPv4 is a scarce resource. It's become a commodity. It's become a traded commodity more than anything else, which means you have to go to a market, you have to buy this, and the prices are going up and up and up. And if you happen to be in an area where there's complete exhaustion, then you're going to have to go to the market and possibly find it outside, which causes a lot of other problems, right? I mean, if you start buying IP address ranges which are not geographically within your geography, then it causes other issues. But nonetheless, the price is going up and up and up. And we think the cost of an IPv4 address is something like 15% of your costing for implementing a service per user. Now, interestingly, right, this is not a sexy story. This is not a technology for a technology story. This is a business story because you can't escape it. You are going to have to go to the market. You're going to have to buy these. You're going to have to support IPv4 going forward, and probably the best way to go about doing that is to use some sort of carrier-grade NAT solution. Typically, you're going to be running CGNAT 44 or 444. Typically, we expect to get between 32 and 64 times a multiplier between your IP addresses that you're going to take on V4. Challenge moving forward, of course, is that you are going to want to move eventually clients as soon as possible, or as they become available, to IPv6. So you need to provide a way to do that. Any solution that you build in here needs to be able to move forward and support one of the various different versions that allow you to straddle the IPv4 to IPv6 changeover. Now, different countries use different technologies. We actually support all of those. So our solution, which is the A10 solution, supports all of those. When you think about it, this is not a smart technology. This is a performance-based technology. This is a technology that really doesn't have to do much in the mode configuration, but it needs to run quickly and efficiently to get the price to the lowest possible value. We support that. The other things that you also need to look at is the fact that you'll need to provide logging functionality, to join logging, to be able to understand who the clients are, who the users are, to make sure that your end-to-end logging makes sense. For lots of reasons. So we've already done this, and I think Community Fibre, may be present, but if they're not here, we've already run a project with these guys. We've run a project with a lot of smaller providers, providing basic CGNAT functionality for them. In fact, I believe that Sam, I'm not sure if he's here today, but he's definitely, oh, hi Sam. He's definitely here with a quote. So we've used this already as a solution. Now, I think if you talk to Sam and any of the people who've used this, what you'll know is it's a pretty simple, basic technology. It runs, you plug it in, it just delivers seamless experience for the customer at a good price point. So look, here's some example costs. And maybe you guys are very technical and this is not so interesting to you, but for a small business, this really does make a difference. What we can see is that if you use CGNAT over buying IP addresses, you can make a saving of $400,000. What's that? £250,000 over a 5-year period of buying IP addresses. So you're essentially paying for a good proportion of what you're trying to do by reusing those IP addresses. To simplify this for you guys, to make it easy, what we've done is we've created an IPv4 V4 Calculator. Come to us, you'll see us in T-shirts and we'll be around and we can show you how to use the calculator, work out your costs, work out how much you're going to save based upon IP address costs. You put them in, we do the calculation, it works out how much you're going to be saving by actually implementing CGNAT. So before I finish off my presentation, part of the other things that we do as a company is we produce DDoS protection devices. And one of the things we've actually seen is that CGNAT devices actually become a target for attacks. Because if you have a piece of infrastructure that's actually doing, well, you've got a massive multiplier of 64 times the amount of users on your network coming through and sharing one IP address. If you can attack that piece of infrastructure and bring it down, you've effectively got a multiplier of sort of 64 times. So we have built-in DDoS protection into our platforms, and we can also link them into our dedicated DDoS protection platforms so that we can redirect the traffic, groom the traffic, and push it back onto our devices. Now, we've seen a massive increase in the attacks, especially since the conflict in Ukraine. We've seen a massive amount of spikes of attacks, DDoS attacks. So, next year, this is only going to increase. It's never decreased. It's going to increase further and further and further. And we have a threat report that is due to be published in about a month's time. And the next time that we have present for you, we're going to present about DDoS and what it's happening and how it's affecting the world. So, I believe I have 2 minutes Q&A if necessary. Anything?
Thanks, Simon. Does anyone in the room want to come up and ask a question? Do you want to come to the microphone? Yeah. If there are multiple people, can you just kind of, leave a bit of distance between each other?
Question. That's the network config, the booking system for this conference. Can you tell me where the IPv4 address is?
I can't even see because I haven't got my glasses on, but there isn't, is there?
There isn't one.
There isn't one. So we'll be saying that we don't need CGNAT anywhere.
Well, there are many cases where you don't need CGNAT.
No, that's absolutely true, and there are very, very many cases, and there's also equally as many cases where you do need them.
Tom Hill, BT.
Hey, Tom.
I really like Pete's question, actually. I thought that was very good. And I could ask you lots of things about data centers and IPv6, but as someone who's staring down the barrel of a lot of CGNAT potentially in the future, I find the premise almost, I feel like it's not where we need to go, and it probably isn't the final solution for the long tail of IPv4. So what do you think is there to help replace us to move towards an IPv4 as a service solution that reduces the reliance upon CGNAT and trying to scale that out?
Do you know, that's a really good question. I have two opinions. So I have an opinion that's based upon the shirt that I'm wearing, and I have a personal opinion. The personal opinion is that up until today, there's been no good commercial reason to move to IPv6. They've been technical reasons, but not commercial reasons, right? And so at the beginning, we saw what I would, always tricky to say this, but almost a religious view of it, right? So the people who believed in it, had the faith, moved very quickly. So we had a very fast move. Then we moved slowly, right?
Are you referring to the price of IPv4 addresses?
Yeah, well, now that's the point. Now IPv4 has become a commodity. So that's driving businesses to actually say, look, because when you go to a business, when we go to a business, right, we have two people. We have the technical people who say, this is the best solution. And then we have the business people who say, this is how much money I've got to spend. If there's not a good reason to do the more difficult thing in their mind, then what they do is they stay with the simple thing. And we've had a situation where we've extended the IPv4 estate beyond where we should have done. I mean, 1996, I remember all the discussions about, what we should do, but it never really took off because there wasn't a business discussion. So look, this is where we are. We are at a point where it's really expensive. And so I think cost will drive the clients over. I also think, frankly, that a lot of the nicer challenges, a lot of the nicer ways to get across would have been if we could have got the end client, right, the modems or whatever, to do part of the translations for us. So lightweight 4 or whatever. So we'd have got some of that, but we've never been able to do that. So what I'm thinking is, personally, I think when we get enough end clients, when we get enough modems, when we have enough devices on customer premise moving over, I think it will shift over. I was sort of hoping that mobile phones would drive it, right, and we wouldn't have so much proliferation of IP addressing in the home. It seems like the Internet of Things has sort of driven us backwards in that.
I'm not sure you've answered the question.
Well, the question is, I don't think it's. I think there's technical reasons why we should move away from it, but I think for pure commercial reasons, I think we're stuck with it, and we're stuck with it for a lot longer than we'd like it, right?
Okay.
Well, that's my opinion. Right?
Complete aside, have you seen the MAP-T deployment in Sky Italia?
Yes, and we do map, and we've got MAP-T. We're putting MAP-T out in several places in Germany as well, but what we tend to do is we tend to use our devices and then we migrate through. So we run, we split it so they'll move over, so they'll have their IPv4, and then they gradually move it over as they can bring up the networks.
Okay, thank you.
No worries. That was unexpectedly exciting.
We're going to have to do a bit over schedule, so we're going to have to skip the remote questions. So thank you very much to Simon.